Our final question of last year's exam, we have an implicit differentiation problem. This time we're only being asked to figure out when or to confirm dy dx as opposed to actually solving for it, though it's the same, right? I just wanted to give the answers so that there was a little less like, did I get it right questions going on. So again, we have a relation. We can see x's and y's on both sides of this equation. So let's go ahead and take the derivative of both sides with respect to x. So derivative of x squared is just 2x. Derivative of negative 2, 0, it's a constant. Dy, or y is going to become dy dx. And plus 5. Derivative of cosine is a negative sign. I'm going to change that to a minus. Times dy dx, right? Anytime we have a y, we're going to have a dy dx in our implicit differentiation. And then we go, okay, well, I need to factor out a dy dx. 1 minus 5 sine of y. And sure enough, if I solve for dy dx, this is going to be 2x divided by all of that nonsense. Done. Whoop, verified. Beautiful. Right? That was all I was hoping for. I think it's confused people that students last semester that I gave the answer. Last question here asked you to indicate the points on the graph where they would have vertical tangent lines. So this was more about recognizing what does a tangent line mean on a graph. Vertical tangent line would be any time we are looking at a line that looks like this. So tangent lines that are vertical, we'd have one here, one here, one here, one here, one here, and one here. So there's 6 different spots where we would have vertical tangent lines for our beautiful graph. These are all, by the way, solutions to when the denominator is equal to 0. And that's what's going to happen. We divide by 0, we get that like undefined slope. So these are all solutions to 0 is equal to 1 minus 5 sine of y. So these are all times that sine of y is equal to 1/5. I refuse to go figure this out. I don't like that it looks like it's at 0, but maybe it's just above 0, and that's why. Anyways, so we don't need to find them. We just needed to indicate where they were on the graph. If it had asked for horizontal, we would have been here, here, and here, but it did ask for vertical, so there we are.